Hey guys, this is chapter 1 in your dimensional analysis book. This is dosage and calculation. The first chapter really is a math review, and if you feel like you need some help with relative value, addition and subtraction of decimals, I would recommend this chapter. If you feel comfortable with this, then you can skip this chapter. These are going to be very important basic math concepts, so I would, if I were you, make sure that you know how to do these. As a healthcare professional, you're going to be dealing with decimal fraction doses daily. Now, it's imperative that you understand decimals, fractions, because you're going to be calculating dosages that can hurt people. So this is very important to remember. Helpful hint, we all deal with decimals on a daily basis in our monetary system. For example, if we go to the store and we buy a loaf of bread, we know that the 2 right here is a higher value than the 4. The 4 is a higher value than the 9. So we're dealing with the same system when we're looking at decimals. If you remember way back in grade school, we looked at places relative to the decimal. And so we start over here. We've got millions, hundred thousands, 10,000s, 1,000s, 100ths place, tens, ones, and then you've got your decimal point, and it starts with tenths, 100ths, 1,000ths. These are very critical that you understand these because we will be dealing with fractional doses. In healthcare, we're only going to be dealing with 3 decimal places after the decimal point. So drug dosages are measured as decimal fractions. They don't contain more than 3 digits. So what we'll be looking at is the relative value between those numbers. What is greater, rounding up, and that will be important in fractional dosages. So when we're looking at relative value, the first thing we look at is there a whole number? The number to the left of the decimal point. The greater the whole number, the greater the value. For example, we know that our 5 right here is greater than our 4. And that's all we have to look at because we're looking at the whole number and looking at our greater value between these two numbers. So we don't have to go on to our places after the decimal point because we know that 5 is greater than 4. Now, when those fractional numbers or the decimal numbers to the right of the decimal matter is when our whole numbers are equal or there are no whole numbers present. The number of figures to the right of the decimal point does not indicate relative value, and we'll see that in some examples. Now, in this particular example, when we're looking at which of these numbers has the greater value, we do not have equal whole numbers. So we look at the whole numbers and we see that 4 is greater than 2 and 3, so the answer is C. This one has the greater value. Let's look at the fractional side. The 0 represents the whole number, right here. The 1 represents tenths, the 2 represents 100ths, and the 5 represents our thousandths place. Now in the example on the last slide, you'll notice that there was a 0 in front of the decimal point. This is going to be a key point. that you will want to remember, because you will get your calculations wrong, or actually you'll get the, when you're answering questions, it will be counted wrong if you have a decimal that does not have a 0 preceding it, if you don't have a whole number. Why is that so important? Well, one, it emphasizes that the number is a fraction. That is incredibly important because it also prevents overlooking the decimal point. Obviously, if we did not have a 0 here, let me just write this out and it won't be very pretty. If we didn't have a 0 here, and we maybe had a very light decimal and somebody overlooked that, then what are we looking at? We're looking at a whole number of 125 instead of 0.125. So this 0 just alerts us to the fact that this is a fractional number, critical in healthcare. Another key point is, if we're looking at the other end of the equation, we are going to eliminate zeros at the end, because that can also be a source of error. So if you have a trailing 0, is what we call it, we do not use that. So 2.30 should be written as 2.3, and we take off that 0. It does not affect the value. It's still 3/10. We see here 30 is 31/100. When you reduce that down, it's 3/10. So it doesn't affect the value. So eliminate trailing zeros, also important. Now when we're looking at fractions or decimals that have the greater value, the first place we're going to look is the tenths place. And so that's going to indicate which of these is the greater value. So we've got a 2, a 5, and a 1. Obviously, B is going to be the answer. Now when the tenths place is identical, we have to go to the hundredths place for the greater value. And here we see that the whole number is the same in each of these. So is the tenths place the same. So we move to the hundredths place, 5, 2, 8. So C is your answer. This is the number that has the greater value between these three. Now you can use a calculator for most additions and subtractions of decimal fractions. The important thing is getting the decimal point in the right place when you're entering the number, otherwise it will be an incorrect answer. As you will recall from grade school, if you are doing it by hand, the important thing when adding and subtracting your decimal numbers is going to be, lining up your decimal points. And same thing over here. You're going to want to line up the decimals for both addition and subtraction so that you get your correct answer. Here's just some examples of adding decimal numbers. And the same with subtracting them. Probably one of the important ones to note here is this one over here, because we don't line them up all over here. We've got to make sure that our decimal points are in alignment when adding and subtracting. Same way with this one right here. So here we can look at our relative value in a dosage calculation. You've got a prescription for 0.4 milligrams. You have on hand 0.1 milligrams. Now which of those is greater in value? Well, it's going to be your prescription, because we don't have a whole number, so we look at the tenths place. The 4 is greater than the 1, and so we know that we're going to do what? Give 1 tablet? Well, no, that's what we have on hand. That would not equal this. Give less than a tablet? That doesn't make sense because we already know that this is a greater value, so the only answer can be C, more than 1 tablet. Let's look at another one. You've got a prescription for 0.125 milligrams. You have on hand 0.25 milligram. So which is the greater value? We don't have a whole number. We look at the tenths number. So what we have on hand is greater than what we have ordered. So our answer is going to be, we're going to give less than 1 tablet. We'll learn about determining how much of that tablet we'll give at a later time. And here's a third example. We've got a prescription for 0.5 milligrams. We have 0.5 milligram tablets on hand. We look at the tenths place, they're exactly the same. We're going to be given 1 tablet. So looking at relative value is important in determining dosages. Practice, practice, practice. You've heard the term, practice makes perfect. So true with dosage calculations. The more you practice, the better you're going to be at it and the decreased risk of errors. Now, when we were in grade school, we made errors on our papers. In math, well, we just got a bad grade. In healthcare, if you're not proficient and accurate, you can cause harm to your patients. So I would encourage that you work through your workbook. You do all those pages, you do the assignments, because this is a very critical part of being a nurse.